Okay, we're working with Eaton to produce a relayout of the NRX production line. Okay, so starting off with the background on the NRX line, this is a custom order line that has high inter-unit demand and produces two types of circuit breakers, the NF and the RF. The NF being much smaller in size with a much larger demand, whereas the RF is obviously larger in size. So for our problem statement, we found that Eaton's NRX production line is inefficient, utilizes poor material management, unnecessary travel, produces excessive work in progress, and has a low production output. So for our deliverables, we obviously want to provide them with a new layout that's going to accommodate for all the new equipment and stations that we added. And we also flipped around the process flow to ensure that the operators can now more easily flex between stations. We're also going to provide them with several balance charts based on the type of breaker and the future demand. And they also requested a benefit cost analysis with a return on investment in a maximum of 2 years.
Okay, so for the current layout, as you can see, there's a lot of material laying around as shown by the red boxes, and only about half of this is actually organized. The other half is pretty much just thrown around. It's like having a bunch of junk drawers. And as you can see towards the left, that single black box by itself, that is a manual tester that they prefer to use instead of the one that's in the line. But using this tester, despite it being faster and more reliable, adds an additional 2 minutes to the cycle time with the loading and unloading since there are no conveyors running through it. And then right below that is the packing conveyor where they will pack the breakers and the package and everything and then put it off for a forklift to pick it up, but it's not easy access, so we're flipping that around too. So this is just a brief overview of the proposed layout. So at the biggest bottleneck station, we added an additional tester there, which is the majority of our cost analysis. We moved that manual tester into the production line. We added a little mini step between stations 5 and 6, which will require an additional worker. We moved the pack conveyor to face the outside aisle. We isolated the subassembly station so that we could discourage workers from staying there all day, because that's a station that we have enough products from. We have enough subassemblies, so we need them to flex elsewhere. So we isolated it in hopes to discourage them. And not shown in the other layout, we moved the accessories kitting area closer to production in that big empty corner, and we moved the greep leader desk into the production area. So everything that's circled here is everything I just talked about. And as you can see, it does look a little bit cramped for some of the testers, but we have it like this because we need the conveyors to run through each machine and not have to get in the way of another machine. So that's the only way we could really do it. And for safety concerns, the conveyors will lift up between stations. So in case of an emergency, they can easily get out.
Here's our current balance chart before any changes. As you can see, the time the operators take exceeds the demand of each takt time. For our new balance chart, we were unable to share any numbers due to confidentiality, but we accounted for union break times and worked with the team at Eaton to use an 18-month forecast to derive a daily production requirement. For our cost analysis, we use a simple and discounted payback period using the cost of each machinery, the cost of hiring a new operator, the additional profit of each breaker from our increased production, and the savings that we calculated from the decreased travel time. We calculated a return on investment of 18 months, but also used a sensitivity analysis of 80% capacity in case our increase in demand was too optimistic. This increased the return on investment by only 1 month. Thank you.